Hi, today I'm going to show you how to create a SQL agent with LangGraph. This was a request from one of my Udemy course participants and longtime viewer on YouTube. If you want to support me while learning how to build applications using advanced AI techniques, promo codes for my courses are in the description. So what is a SQL agent? A SQL agent is a system that takes natural language as input, looks at a database schema and converts the natural language into the appropriate SQL statement. Based on the result, the agent then generates a natural language response. So this is what we're gonna build. We assume that a user is logged in with a specific user ID. First, we retrieve the current user name based on the ID. Then we check the relevance of the question by letting the LLM examine the schema to determine if it can answer the question. If it can't, it will generate a humorous response instead. If the question is relevant, the agent creates a SQL statement. If the statement executes successfully, we then save the output and let the LLM generate a human-like response. However, if the SQL statement produces an error, we update the original query to make it easier to convert to SQL and try that again. We attempt this process up to 3 times. If we still can't resolve the issue, then the agent will exit with a message indicating that it was unable to complete the task. For this video, I assume that you've got at least basic knowledge of LangGraph. If you don't have that knowledge, then please watch my introduction to LangGraph first. Let's jump straight into the code. Okay, I'm now in Visual Studio Code, and as you can see on the left, we've got multiple files, and we are in the SQL folder where we've got 2 files, setupdb.py and the SQL IPython notebook. You can get the complete code in the link in the description. So we first, to use or create a SQL agent, have to create a database and define a schema. So this is what's happening in the setupdb.py. So we first import multiple classes and functions from SQL Alchemy. So we use SQL Alchemy as ORM, so as Object Relational Mapper. So what we're gonna do here is that we define classes to create our tables, so we don't have to write SQL statements. And what we're gonna do is that we create 3 tables. So the first one is the user table. This is where we can store our users. Every user has got a special ID, a name, age, email, and a link to the order table. Then we've got a food table, also with an ID, name, and the price of the food. And to create an order, we just link these 2 tables. So we have to provide a food ID and a user ID. This is how we can create a new order for a special user. So we always have to provide a food ID and a user ID. Then we're gonna create a file or a database URL, and we're gonna use SQLite so we can save that file on our local machine. So that's the minimalistic way to do it. So what we're gonna do is that we use create engine, we pass our database URL, and then we use that engine and pass it to this base metadata create all, and this bind arguments takes our engine. So this is how we create our database. Then we also create a session to add our users, and we do it like this. So we just create a list of 3 users, Alice, Bob, and Charlie. So we can use Bob to then make an order for food. Then we're gonna use commit to save that in a database. We're gonna store some foods like pizza margherita, spaghetti carbonara, and lasagna for $12.50, $15, and $40. We also save that in a database. And then we also gonna create some dummy orders. So here we pass only the food ID and the user ID. So this is an order for Alice. So Alice has got the ID 1, and Alice orders pizza margherita. So that's one order for Alice. We do the same with food ID 2 and user ID 1, and also for food ID 3 and user ID 2. This is just to have some dummy orders in our database. And then we just close the session and run that. So this is how we're gonna initialize our database. So first we have to go to the SQL folder, and there we just run Python and then setupdb.py. Now we can see that we've got this example.db file, and now we can access it with our agent. So let's scroll up in our agent, and what we're gonna do is that we first gonna import some classes again from SQL Alchemy, but now also from LangChain. So again, I just defined the user tables. I could also import it, but yeah, it doesn't really matter because it is some dummy code. But our agent, of course, also has to know these tables, and this is why we define it here again. But it's exactly the same like in the setupdb.py. After that, we can create our agent. So to create our agent, we first have to use agent state. Agent state is used to pass the information from one node or one function to another node or another function. So this is why we created like this. We could also use pedantic, but I think typedict is a very clever way to define our agent state. Then we've got our first function. So this is get database schema. There is an inspect function from SQL Alchemy. The inspect function will create an inspector object with multiple methods, like get table names or get columns. And we want for the LLM to have that in a nice and visually appealing way, so it's easier to understand for the LLM what's actually going on. If you just would use get table names and get columns, it would look quite messy and it would definitely decrease the performance. So the next function is get current user. And what we're going to do is that we pass another object to the invoke method, which is a config. And this config object allows us to pass information at runtime. So we don't know the user ID up front. So this is what we want to pass dynamically. And this can be done with this runnable config. We extract from that this configurable key, and then from there the current user ID. We also set a default value of none, so we can check then if we actually got this user ID. And if we don't have that user, we will set the current user to user not found and will return the complete state. If that's not the case, then we will run the query method on the user table and filter for the user ID with the user ID that we pass here. And we will extract the first object here. And then we set the current user to the user.name attribute. So this is what should return Bob for ID 1. And we want to do that because in the LLM, we want something like, hello Bob, thank you very much for your order. So the LLM should always speak personal to that user. And we don't want to say, hey, user ID 1, thank you for your request or something like that. So this is why we extract the user name. Okay, so that's done here. And now we want to check the relevance of the question of the user. And here we use a pedantic model, we inherit from that, and we can use that to get structured output. So we've got this check relevance class with a single attribute, and here we provide a description for the LLM. So check relevance should always return relevant or not relevant. And then we define the function check relevance where we extract the question, and we also extract the database schema. So now we've got the question and the database schema. And we want the LLM to check if that information is related to the database schema or not. And then we want to use this as system message here. So that's the system message and the human message. And here you can see we pass the schema, and here we pass the user question. And then the LLM with structured output will evaluate if it's relevant or not. We use the invoke method and extract the relevance attribute and assign that to the relevance key in the state object. We're going to create another pedantic class for the SQL query. Again, we inherit from pedantic, set up a field, SQL query, the SQL query corresponding to the user's natural language question. So this is what we want the LLM to do. So we extract the question and the current user and the current database scheme. So based on that information, we want that the LLM converts that natural language into SQL queries based on this schema. And here you can also see we restrict that. We want to ensure that every query is related to the scope of the user. So we don't want information from other users inside there. So after that, it's the same like before. We have got a chat prompt template where we pass our system message and the user question. And we're gonna use structured output. We pass the pedantic class, create our chain, use the invoke method, and then save the SQL query, which is this SQL query attribute, inside the state with a new key. So that's the same like before. And now we want a function to execute the query. So we're gonna extract from state. Here it was saved, and now in the next node we can use it. So we extract the SQL query and we strip white spaces or anything that is not related to the query. And what we're gonna do here is that now we've got our SQL text, and we're gonna use the execute method where we just pass in this as text. So as you can see, we've got this result variable. So why not just use that and return that? So in my opinion and in my experience, it makes sense, and it makes it easier for the LLM to post-process that information a little bit. So we're gonna use this format with a semicolon, which makes it a little bit more readable for the LLM. And this is why we're not just gonna save that and overwrite this as state, but we're gonna post-process it a little bit. So here we not just gonna pass the normal result, but we pass the formatted result here in this state key query result. And if everything worked, then we're gonna also set SQL error to false. This is used to determine whether we want to rewrite the question and regenerate a query again or not. Okay, so next function is generate human readable answer. Here we take a lot of information. The SQL query, the query result, the current user, the query rows, and if we've got a SQL error or not. So if we've got an error, we want to tell the user in a clear way that we've got an error message and that we want to inform the user about this issue. If we don't have an error, then we're gonna check if our SQL statement started with select. So we make this a little bit more deterministic and not directly let the LLM use that information. So if we start with insert, for example, we can use something different because we know insert is the only case where we create an order, while select is something like give me all of our orders. So we can provide different system prompts or different instructions for the LLM. And here we can see, in this case, we handle non-select queries differently. Formulate a clear and understandable confirmation message starting with hello, that the order was successfully processed. So this is when we got like an insert statement, for example. Then we scroll a bit down, and as we can see that we've got our prompts, we've got our LLM, we use the pipe operator to create our chain, and then we're gonna use the invoke method and get our answer. We could use another new key, but we can also override query result because we know we don't want to work with that query result, so we can just override it. But let's say if we would need it, then we also could create another new key. Then we return a state, and then we're gonna create another class. This is for rewriting the initial question. So if we don't get a good result by our SQL statement, then we can rewrite the original question. And here we pass a single attribute again, that is the rewritten question. We save that in the question attribute. The function is regenerate query. We extract the question, and then we want the LLM to reformulate the original question to enable more precise SQL queries. So we will create a different version of the initial question. We use the invoke method of our chain again, and we're gonna store the question inside the state with the question key. So we overwrite the initial question. And then very important, we're gonna use the attempts key and increase that value by 1. Because otherwise we could end up in an infinite loop, because we always write a new question, the query doesn't work, we write it again, the query doesn't work again, and so on and so on. So this is why we want to exit after 3 attempts. Okay, so the last one is generate funny response. So if we got a message that is not related to our database schema, then the conditional edge will route us to this function. And here we just pass the prompt, you are charming and funny assistant, to respond in a playful manner. And it should answer to the user in a playful manner, so nothing really special is gonna happen here. So we again save the message in query result, and this is what we're gonna return to the user. Okay, so last note is and max iteration. So this is what we're gonna return if we run into this infinite loop error. Then we just want to return, please try again. We could also use an LLM, but I think it's not really worth the hassle. So we're just gonna return the string, please try again. Okay, so now we've got all of our node functions, which will be executed in our node. We now need our router functions, where we can route from one node to another node dependent on this string here. So first, for our relevance router, we're gonna extract the relevance key from the state, and we check if that's relevant. Then we want to convert the user question to SQL, and otherwise, if it's not related, then we're gonna generate a funny response, and we're gonna return that string to make that routing possible. Then we're also gonna check the attempts. So if the attempts are smaller than 3, we want to return the initial query to SQL. And if that's not the case, we want to route to this node. So and max iterations, and we just want to return that string. Then the execute SQL router. So here we're gonna check if we've got an error in our SQL statement, And if that's not the case, then we're gonna generate a human-like response. Otherwise, we want to route to the node regenerate query to generate the query again. Okay, so we've got our node functions and our router functions. Now let's define our workflow or our agent. And for this, we're gonna use StateGraph. So that's a class we imported before, and we pass the agent state. So this is how we're gonna define our workflow. Now we have to define or add our nodes and edges. So we add get current users, there we add the get current user function. For check relevance, we pass that key and pass that function. So that's always the same. We're gonna pass that name and gonna pass the function with the same or almost the same name, execute SQL query, and so on and so on. Now we want to define our edges. So we've got get current user, and from get current user, we want to route to check relevance. So that's always the first step. We always want to get the current user and then check the relevance of the question with an LLM. But based on that, it depends, is it relevant or not? We want to route to convert to SQL, or we want to route to generate funny response. So this is how we're gonna do that. We provide this key, check relevance, then we pass the router function, and then we pass a dictionary with the values where we want to route to. The next one is a normal edge, not a conditional one, because after creating our SQL statement, we of course always want to execute it. But after executing it, we want to check if it created an error or not. So this is done with the execute SQL router function. And based on that, we want to regenerate the query, or we want to generate a human-like response. Again, we provide here our key for this edge, then the router function, and here the dictionary with possible options where we want to route to. Then again, conditional edges, here regenerate query, and we want to check if we want to route, and we want to route to convert to SQL again, or otherwise, if not, then we want to route to the max iterations node. Okay, so then the last edges are generate human answer, there we route to the end node, and here another edge, generate funny answer, again to the end node, and also max iterations to the end node. This means that the workflow of the agent has no end. Okay, so where do we actually start? This is done with set entry point, and we start our agent with get current user. Okay, now we've got everything. We got our node functions, we got our router functions, we created our workflow, and we're gonna use compile to create our app object. Okay, so what's always very helpful is to display the agent. This can be done here. As you can see, this is the workflow. It looks a little bit more complex than it actually is. We've got get current user, then check relevance. Here we auto convert SQL or generate funny response. And here we've got our potential loop where we're going to execute the query, regenerate it, and then based on max iterations, we're going to end. Otherwise, we're going to generate our human answer. And all of these three nodes end with the end node. Okay, now let's create our user. So dynamic is our user ID. Let's say we are logged in with the user Bob, who has got a user ID 2. And this is what we're going to provide, let's say, as fake config. Now, you're normally logged in a real world application with a, say, a JSON web token who got this information in the payload. So let's create that, and we pass that to the invoke method as additional config object. And our query is create a new order for spaghetti carbonara. So let's try that. As you can see here, current user is set to Bob. So we extracted information from that user ID. Here we can see that's the SQL statement that is created. And at the end, the human-like response is, hello Bob, your order for spaghetti carbonara has been successfully placed. So let's check that out. For user ID 2, I created this little helper function, and we can see that we've got now spaghetti carbonara. This is the user ID that was created in the setup.db file. So that's new. And we can see that this worked. So we can actually try that again to see the difference. So we should get another order for spaghetti carbonara. Let's try that again. And now we can see that we added a third entry here in this dictionary. Okay, then we've got tell me a joke. Here we can see it was determined as not relevant, and we get a funny response. Okay, so third question is show me my orders. So this should create a select statement. Here we can see select food name and so on and so on. And that's the SQL statement that was created. And we can see the answer is, hello Bob, you've ordered lasagna and spaghetti carbonara for $15. So as you can see, this works. So based on the schema of the SQL database and the user input, the LLM is able to convert that into an SQL statement, then inserts or collects the correct information from the database and again responds in a human-like manner. I think this is a pretty cool way to create this SQL agent. If you think so too, then please like my video and subscribe to my channel. Thank you very much for watching. See you in the next video. Bye bye.